this is lead code problem number 26, and the problem is we just need to remove duplicates from sorted array. Okay, and the statement is given an integer array nums sorted in non-decreasing order, and remove the duplicates in place. That means we are not allowed to take any extra space to solve this problem. Okay, such that each unique element appears only once, and the relative order of the element should be kept same. Okay, order should be same, and then return the number of the unique elements in the num. So basically we just need to return the number of unique elements. We just need to return the length of the unique element. Okay. So yeah, the consider the number of unique elements of nums is k. To get accepted, you just need to do the following thing. So basically change the array nums such that the first k elements of the nums contain the unique uh, elements in the sort in the order they were present in the nums initially, and the remaining elements of the nums are not important, as well as the size are not important. And we just need to remove, we just need to return the key. Okay, so basically we just need to return the size of the unique element in the particular array, in the given array. Okay, and yeah, we just need to place all the unique array, all the unique element to the very fast, to the very fast positions of the array. So you can consider this example. So this is a sorted array, and it has also contained duplicates. So what I need to do, we need to place all the unique elements to the very fast end. So you can see we have only the unique elements is 0 1 2 3 and 4. So we placed here, you can see the answer array actually placed all the unique elements to the very first positions. Okay, for this array. And yeah, we just need to return 5 because this we have only 5 unique elements. That's it. Now, yeah, let's analyze this example to find some optimal solution to solve this problem. Okay, so this is the example, and with the help of this example we are gonna come up with some approaches, some algorithms to solve this problem. Okay, so you can see this is the array that is sorted. So let's think something like, yeah, we are not allowed, I know that we are not allowed to take extra space to solve this problem, but just forget this extra space things and just think some approaches to solve this problem with some space first of all. Okay, then we'll think about extra space, not extra space. Okay, constant space. Okay, so we just need to do, we just need to have, we just need to achieve the unique element. So there is a data structures that is nothing but hash set. Okay, so we have hash set data structures that only contain unique elements. Okay, so probably we can use that hash set, okay, to solve this problem. Okay, so basically what I need to do, we need to iterate through this array and need to put every element to this hash set. So first of all we have 0, so we'll put 0, then we'll again have 0, but as we already said that hash set only contain the unique element. So if we put 0, then it will only have 1 0. Okay, it's not gonna contain again 0, or not gonna contain the duplicates element, right? So yeah, the next time we'll be having 1, so this will 1 again. For this one we'll have only 1 again. For this, and this is 2, so we'll have 2, and this is again 2, this not gonna contain again 2, so we'll have 3, so this is 3, and again 3 is duplicate. So yeah, now we have 4, so this is the 4. So you can see right now we are already get all the unique elements, and basically finally we can return the size of the hash map, hash set, and that is nothing but 5. Okay, so yeah, that is the approach, but the thing is we are using hash set, so it's gonna take extra space that will be very approximately big of any extra space. Okay, yeah, so as we already said that we are not allowed to take extra space, so we can't use this approach or has said to solve this problem. Let's analyze or try to find out some other algorithm to solve this problem. Okay, first of all, let's erase all this from the board. Okay, So, to solve this problem, optimally or with, constant space, we need to think about approach that will be nothing but two-pointer approach. Okay, so in two-pointer approach, we just need to have two pointer, and let's say we have two pointer. First one is I, and the second one is J. Okay, and I will start from zeroth position, and J will start from one position. Okay, basically we are considering this as a zero base index. Okay, that's why. And what will happen with this pointer? Okay, J will increase every time by one, and I will only increase by one place if we got different value for this two pointer. Okay, so basically I'm saying that right now you can see that I is at zeroth position and J is at one position. So first of all, we'll compare these two value. Okay, so you can see these two value are equal. So if both are equal, then what will be doing, will only, okay, will only increase the value, increase the J pointer by one place. So right now you can say J is here. Okay, and yeah, and the I will be at its own place. Okay, and again we'll be checking that if both value are equal or not. Okay, and you can see that both the value are different. Okay, so if we get the different value, then what we'll be doing, will first increase the value by one, increase the Z pointer by one. So so you can see that say I will be here right now, and then what will be doing, will be putting the value of J at the position of I. So right now you can see the value of J is nothing but 1, so we just need to put 1 here. So this is right now not 0, this is 1. Okay, we just rewrite this value. Now as we know that every time J will increase by one place, so J will be here right now. Okay, so it says here. Now again, first of all we just need to check this two value, and both are value are equal, so we only need to increase the value of Z only. Okay, so Z will be here. Now again these two value are equal, so again let's increase the Z by one place. Okay, so right now J is here. Now this time you can see the value are different. So if the value are different, what we need to do, we need to, first of all we need to increase the I pointer by one place, so I will be here, and then we need to put the value of Z at the position of I, right? So the value of this place right now will be nothing but 2. Okay, that as simple as that. Okay, and again we know that the Z pointer always increase by 1. Okay, every time. Okay, every iteration it will increase by 1. So right now Z is at that position, so you can see both are equal. So again Z will increase by 1 pointer. Okay, so Z will be here, and right now you can see both are different values. So first let's increase the value of I pointer by one place, so I will be here, and let's put that value here. So right now it will be not 1, it will be 3. Okay, yeah, and again we just need to increase the J pointer by one place, so right now J will be here. Okay, now again these two are equal values, so we just only need to increase the Z by 1, so Z will be here. Now you can see both the value are different, so what will we do, first of all we need to increase the I by 1, so I'll be here, then at the position of I we need to put that value, that means nothing but 4. Okay, so it will be rewrite to 4. Okay, yeah, and then I just need to increase the J pointer by 1. If we increase the J pointer, so you can see that right now it's just out of bound. Okay, right now it's out of bound, out of the array index. So at this position we can say that yeah, we just iterated all the elements of the array and we completed our task actually. So now what I need to do, we need to just return the I pointer plus 1. Why pointer plus 1? Because right now you can see the index of I is nothing but 0 1 2 3 4, plus 1 means 5. So basically totally we have 5 unique elements in this array. So 0 1 2 3 4, these are totally actually 5 elements, unique elements. Okay, that is the actual result. Okay, if we erase everything, then you can say the result is similar. Okay, so now let's jump into the code section and code this algorithm. Okay, now let's code this approach, two pointer algorithm. Okay, so first of all we just need to take a pointer, and let's say the pointer name will I, and it will start from 0, and the next pointer will be j, and it will be starting from 1. Okay, so now what I need to do, we need to make a condition. Okay, while what, while j is nothing but less than, okay, I dot, I mean total length of the array, that is nothing but nums dot length. Okay, so until j is less than, the loop will continue. So every time, first of all, we just need to check whether these two value are equal or not. Okay, so what we need to do, we just need to check the value. Okay, we will be checking that if the value of ith position or jth position are different or not. Okay, so nums of, if nums of I is not equals nums of j, okay, then for this what I need to do, first of all we need to increase the I pointer by 1 plus, then we need to initialize at the position of I with the value of the j pointer, right? So that will be nothing but nums of I will be initialized to nums of, with nums of j. Okay, and as simple as that. Okay, if both are equal, then we'll be doing the same, and otherwise what we need to do, we just need to increase the j pointer by 1. Okay, so that is the thing. So what we did, actually if both are different, okay, in that case what we need to do, first of all we need to increase the I pointer by 1, then we need to place the z value at that I pointer, and we again need to you know increase the j pointer by 1, because you can see that every time j pointer will increase by 1, whether both are equal or different. Okay, j, j gonna increase by 1 every time. Okay, again, and yeah, it's working well. Now let's submit this code to check whether we have some error or it get accepted. So you can see it get accepted. Okay, so that is the thing. And one thing I just like to mention, that yeah, we did this with this while loop, but we can also did the same, okay, with the help of a simple for loop. Okay, and that will be also very simple. Let's say we have only one pointer, that is I, and another pointer will be using with the help of the loop itself. So let's, we have a for loop, and we have they will start from 1, and they will go up to the length, so nums dot length. Okay, and every time, we already know that every time j gonna increase by 1. Okay, whether it's equal and not equal, right? That's why this loop actually work the same. Okay, so we just, here we just need to check, okay, whether these two are different. Okay, if the two value are different, that means if nums of this I is not equals nums of this current, I mean this j, then what I need to do, we just need to do the same. What we just need to increase the I by 1, so I'll be increased by 1, then at the position of I we just need to initialize the value of j, right? So nums of j. Okay, yeah, that is the thing. And here we don't need to increase the j pointer, because this loop itself gonna increase the j pointer by 1 every time. We just only need to do the thing, and yeah, the return statement will again the same. Okay, now let's run this, and you can see it's also working very well. Now let's submit this, and yeah, it also gets submitted. Yeah, that's it. And obviously the time complexity is linear, that is big of